Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know about similarity for your upcoming test. So two shapes are said to be similar if pairs of corresponding angles are equal and pairs of corresponding sides are in proportion. Basically, if two shapes are similar, one of them is just a larger version of the other. So looking at these two shapes here, we have pairs of corresponding angles are equal. If you see angles marked with the same thing, like an X or an arc, it means they're equal. So these two are equal, these two are equal. So these two sides have pairs of corresponding angles equal. The angles that match up here are equal. It also turns out their sides are in proportion because longest side divide longest side. So the ratio of the longest side to longest side is 10 to 6 or 10 over 6. The ratio of the shorter side to shorter side is 8 over 4.8. Both of these numbers are the same. They're both equal to 5 over 3 or 1.6 recurring. That's what we mean that sides are in the same proportion. Another way of saying this is that the scale factor is consistent. It's the same for all. So to go from 6 to 10, you need to times by 5 over 3 or 1.6 recurring. And to go from 4.8 to 8, you need to times by 5 over 3. So this number 5 over 3 is called the scale factor. Sides in proportion means the scale factor is the same for each pair of corresponding sides. For the two longest sides in the shapes, two shorter sides in the shapes. So these two shapes are similar. On the other hand, these two shapes are not similar. So it turns out that their sides are not in proportion, their angles are not equal. So this is an equilateral triangle. So for an equilateral triangle, all its angles are 60 degrees. Every equilateral triangle has angles 60, 60, 60. So you can see there's a pair of corresponding angles that are not equal. The smallest angle in this triangle is 35. The smallest angle in this triangle is 60 degrees. So we have a pair of corresponding angles that are not equal. Now here the sides are not in proportion. To go from 4 to 5, you would need to times by 1.25 or 5 over 4. That's the scale factor for these two sides. But the scale factor for these two sides is not the same. So we would need to go from 4 to 3 by timesing by 0.75. The scale factor is different for these two sides than for these two sides. In fact, it's hard for us to tell which shape is larger because these sides are longer, but this side's shorter than the ones here. So these two shapes here are not similar. All right, let's now look a bit more at specifically triangles. So we're going to look at situations where you have two triangles and you have to determine whether or not they're similar. So for triangles, it's actually a bit easier. You don't need to check that every pair of sides is in proportion and that every pair of angles is equal. Instead, you use one of 4 tests. So if the two triangles satisfy one of the tests, then they are similar. If you can't use any of the tests, they may or may not be similar. So here in each diagram, we have two pairs of triangles. So it turns out they're similar in all of these cases. Now, which test that proves similarity, it depends on the information you're given. So if I'm given each of the side lengths here, I have to use the test SSS. So S means sides in proportion. These two triangles are similar because they have 1, 2, 3 pairs of sides in proportion. So here 12 over 6 is 2. 10 over 5 is 2, and 8 over 4 is 2. The scale factor is 2 for each pair of sides, for the longest side in each shape, for the middle side in each shape, and for the shortest side in each shape. Each side in this larger triangle is twice as long as its corresponding side in the smaller shape. That's what a scale factor of 2 means. The sides in the larger shape are twice as long as the sides in the smaller shape. So that's how we use the SSS test to check. So if I was just given this information and not given these two sides, I would need to use the SAS test. So that's where you have two pairs of sides in proportion and the angle between is equal. Note for SAS, it has to be the angle between the two sides. So here we have two sides, it has to be the angle between. Now I know these two angles must be equal because they're vertically opposite. So we have two pairs of sides in proportion and the angle in between is equal. That's when we use the SAS test. Again, to determine whether or not sides are in proportion, look at where the scale factors are consistent. 8/4 is 2, 10/5 is 2. The scale factor for these two sides is the same as for those two sides. So I have two sides in proportion, one pair of equal angles in between. So if I was just given this information here, I would have to use the AAA test. So two pairs of triangles are similar if all three of their angles are equal, if they have three pairs of equal angles. So in this triangle, I already knew these two angles have to be equal because they are vertically opposite. Now, if you're told these lines are parallel, this angle and this angle must be equal because they're alternate angles over parallel lines. This angle and this angle must be equal because when you have parallel lines, alternate angles are always equal. So note when you're using the AAA test, you actually only need two pairs of equal angles. Because if you have two pairs of equal angles, the third pair of angles must be equal because angles in any triangle add to 180 degrees. So if you get two triangles and you don't have at least four sides, that is, you don't have at least a pair of side lengths in each of the two triangles, then you'll have to use AAA. That's the only option open to you. So there is one more test we can use for similar triangles, and that is the RHS test. So R means right angles, so if each triangle has a right angle, and H means hypotenuse, S means sides. So two triangles will be similar if they both have a right angle and their hypotenuses and another pair of sides are in the same proportion. So here, the scale factor for the hypotenuse is 12/8, which is 1.5, and the scale factor for the other pair of sides is 9/6, which is also 1.5. So here the scale factor is consistent. This side here is 1.5 times the hypotenuse in the smaller triangle. This side here is 1.5 times as large as this side. So we have two pairs of sides in the same proportion, one hypotenuse, two, another side, and they also have a right angle, so the RHS test proves that they are similar. All right, let's now look at using scale factors to find unknown sides. So we know that if two shapes are similar, their sides are in proportion, and we can use this to calculate unknown sides. So in order to calculate unknown sides, you first have to calculate the scale factor, which is the side in the larger shape, divided by the length of the corresponding side in the smaller shape. You then multiply or divide by the scale factor, depending on whether you're finding a side in the larger or smaller shape. So that probably doesn't make a lot of sense. Let's go through some examples, and hopefully it does. So let's look at these two shapes here. So I'm telling you that they're similar. I want to use that to find the value of x and y. So first I need to make sure I can match up corresponding sides. So that can be a bit tricky. Sometimes marking the angles will help you. So for example, this is clearly the largest angle in the smaller shape, so it will correspond to the largest angle here in the larger shape. This one here looks to be the smallest angle, so it will correspond to the smallest angle of the larger shape. So you can see this angle here is basically directly opposite the largest angle, so it's going to be directly opposite the largest angle in this larger shape here, and I'll just call this one alpha. It must correspond to that one there. So this will help us match up corresponding sides. See, for example, 30 is the side touching the x and the dot. It corresponds to the side touching the x and the dot. So 30 and 20 are corresponding sides. So the scale factor is 30/20. Side in larger shape divided by corresponding side in smaller shape. So that gives us 1.5. That means that each side in this shape is 1.5 times as long as its corresponding side in this shape. So for x, which is touching alpha and the dot, it corresponds to 18, touching alpha and the dot. So because x is in the larger shape, I times by the scale factor. So x will be 18 times 1.5, which gives us 27. Now when I want to find y is in the smaller shape, so I need to divide by the scale factor. Y corresponds to this side here. Both are touching the x and the arc. So y won't be 33 times 1.5, it's 33 divided 1.5, which is equal to 22. All right, let's look at this example here, which is a bit harder. So here it's easy to calculate the scale factor. It's just 24 over 18, and 24 over 18 is equal to 4 over 3, or 1.3 recurring. So now let's find x and y. Well, this is a little tricky because I don't have x's corresponding side in the large. So it turns out here, this side here I'm just going to call x, but its corresponding side, this length here, is x plus 8. So because x is in the smaller shape, I times by the scale factor. So if I times x by the scale factor, I get the length of the side in the larger shape. To solve this equation, subtract x from both sides, subtract 1x from both sides. So 4 over 3 minus 1 is 1 over 3. So I get 1/3 of x equals 8. X equals 8 divided by 1/3, which is 24. So this length here must be 24. Now let's look at finding y. Well, y is sort of part of the larger shape. I need to find this length here to find y. Well, the side in the smaller shape is 30. So if I times that by the scale factor, I actually get 40. This whole length here must be 40, because 40 is 30 times the scale factor. So that, of course, means that y has to equal 10, because 30 plus 10 equals 40. All right, let's look now at a worded problem. So at the same time of day, a tree makes a 3-meter shadow, and a person who's 2 meter tall makes a 1.5 meter shadow. Calculate the height of the tree. So if you're not given a diagram, draw the diagram. So let this be the tree. The tree makes a shadow that is 3 meters. So here we can assume that the tree is at right angles to the ground. We want to find this height here, so I'll call it x. So at the same time of day, we have a person who is 2 meters tall, and they make a 1.5 meter shadow. Here we have a right angle. We can assume the person standing perpendicular to the ground. So it turns out that the angle the sun makes with the ground will be equal in both cases because it's the same time of day. So here we have 2 pairs of equal angles, means that the third pair of angles must be equal. These 2 triangles are similar by the AAA test. So because they're similar, sides will be in proportion. So the scale factor here is just 3 divided 1.5. It's just side in the larger shape divided by corresponding side in the smaller shape. So the scale factor here is 2. Sides in this triangle are twice as long as corresponding sides in this triangle. So x is in a larger triangle, so we times by the scale factor. It's the height of the person times the scale factor. It would just be 4. The tree is 4 meters tall. All right, thank you so much for tuning into this video. Best of luck studying for your test, but I know you're going to ace it. This has been the luckiest maths teacher in the world. Have a great day.